this show on the road here, folks. So, I think everything. We have one more homework assignment for the semester. That's it. Everything else is in and graded. And reminder, you get 2 dropped homework assignments. So if you have like 100% in homework already, you neglecting to do the final homework assignment will not hurt your grade in any way. Just reminder. I didn't get a lot of responses in the survey from people on whether they wanted the doubled high test score or a retake. So I just put in doubles for everybody. If somebody doesn't want that, you can contact me. And we'll make some other arrangement. But I figure just giving everybody an idea of kind of where they stand as of right now before going to spring break. And like, if you have some stuff you have to get caught up on, you know, where you're at or whatever pretty thoroughly. After the test last class, I'd set out these 2 IB exams. These are last year's paper 1 and paper 2 for the IB exam, and asked everybody to grab one on their way out. If you forgot to do that, grab one of those here today. Doesn't have to be right now, but like before you go, they're just sitting right here. That's what we'll be working on next week. It's just like give you time in class to work on, work through this. I'll have like my own worked out key, and I'll put up the mark schemes or whatever that tell the IB graders like what are we looking for. I'll put those in the OneNote at some point and let you guys, so you guys can check through stuff. So I have one last set of topics to go through. Again, this will be a homework only chapter. No quiz, no test. And it's only 2 sections. So that is the plan here for our final day of like me teaching stuff. And then we're done. How's that sound? Pretty righteous, right? All right. So the first section is about circles. So I have this picture to just kind of go over some basic circle vocabulary. So a segment of a circle is like some little shaded region of it. A sector is like the same shade, like a shaded region, but the difference with the sector is that it's like a pizza slice where the point of that sector is the center of the circle. A chord is just some line that goes through the circle, not necessarily through the center. An arc is like some part of the circumference of the circle. The big thing for what we're going to look at in section 1 here is this central angle. And it turns out this central angle is going to be necessary for calculating both sectors and arc lengths. So that's kind of the big takeaway here. So suppose you have a pizza of total area of 120 square centimeters. The pizza is cut into 8 equal slices as shown in the diagram. What is the area of one slice? This is like basic division, right? It's 120 area total. We put it into 8 equal slices. Booyakasha, we're done, right? So that comes out to be 15, I think. Is that right? Sometimes it's hard to mental math in the mornings. I think it's 15. Let's check real quick. Yeah, great. So what's the total area of 3 slices going to be? Three times 15. Oh my gosh. Mr. Kulak, it's so hard. the takeaway here is going to be the area of the sector is that central angle divided by 360 times pi r squared. So it just turns out that the central angle divided by 360 in this case was 1/8 because the circle was divided into 8 equal slices, right? But that's the formula. That's what you'll use to deal with this. On golf courses, the grass is carefully watered to make sure the grass receives neither too much nor too little water. On a certain area of the golf course, a lawn sprinkler is set to spray an arc of 150 degrees with a spray distance of 3 meters. Calculate the area of the grass watered. So we're just looking for the area of some sector. So it's literally going to just be the central angle divided by 360 times pi r squared. Done. Super simple, right? Last example, some plane routes come very close to flying over the North Pole. The route from Dubai to Seattle comes very close to the North Pole. In this case, the distance of the flight can be estimated by the arc length. Given that Dubai is at 25 degrees north and Seattle's airport is 47.5 degrees north, as shown in the diagram, estimate the flight or the length of the flight between the two cities. We know the radius of the Earth is approximately 6,370 kilometers. I didn't know that. Calculate the distance along the Earth's surface that the plane must travel. Okay. So basically we just are looking for this arc length, right? So I need to first calculate this central angle. So I notice the equator is like a straight line. So that's 180 degrees. So the piece that I need is just going to be 25 and 45 subtracted from 180. I'm sorry, 47.5. That's such an inconvenient number. So that's what, 155, 107.8, I think. Yep. And then pi r squared, we're told the radius for the Earth. Part B says, assume that the plane flies at a constant elevation of 10 kilometers above ground level. Well, the only thing that's changed here is the radius then, right? Instead of being along the Earth's surface, I just need to add 10 kilometers to the radius of the Earth. And I'm done, basically, right? Just type in my calculator, bingo, bango, bongo. Feel okay? So that section is done. That's super easy. Probably something you remember from geometry even, hopefully. They're also very common ACT questions dealing with sectors and arcs and stuff. What you've probably never seen before, and I guarantee will be a question on the IB exam, has to do with these Voronoi diagrams. So this is an actual real world thing that could be used in industry. So the canonical example of this is like cell phone towers. So you build a cell phone tower, right? And it services cell phones in a given area. and you have another cell phone tower somewhere over, that's servicing cell phones in that area, but like you don't want them overlapping and fighting over which tower is servicing the cell phones. So what you need to do is kind of divide up the region in which the cell phone tower is going to be servicing. So that's kind of what this Voronoi diagram is describing. So like the letters are the locations of your towers, and the areas or the lines are like blocking off the area in which that cell phone tower is servicing. So we call the little shapes in there, we call those cells, and the letters are the sites, and the lines that make up the shapes are your edges, and the corners of them are called the vertices. So the idea here is that like any point inside a cell, the closest site to it is going to be the site in that cell, right? So the place where there's like a tie is if I'm on the edge, then the distance from that point to either of the sites that divide that, or that edge divides, would be shortest. Or if I'm at a vertex, then it would be the shortest distance would be to any of the three sites that are divided by that vertex. You kind of get the idea? Okay. So if we want to identify the closest site to 30, 20, I would just plot 30, 20, which looks like it's there-ish. So that would be closest to site A. Everybody's okay with that because it's in the cell of site A. Give a coordinate of a vertex equidistant to 4 sites. So what I'm looking for here is a vertex that intersects, or that's made up of 4 lines coming into it. So one of them could be this one, right? 4 lines come into that. Is there another one? Don't see one. I think that's it. So let's at like 25. Estimate the coordinates of a point equidistant to sites A, E, and K. So that's going to be a vertex that borders those two. So I see A, E, and K. So like that vertex there bounds those 3 sites. So whatever that is, like 19 and then 26 or something. Ideally, this has graph paper and I could read the grid and tell you exactly, but the copy or the translation from the scan is not great. Explain why the diagram cannot give us a point equidistant to C, F, I, and L. So C, F, I, and L. So the reason there would be that like they don't share a common vertex, right? So there's no point equidistant. So the next one says point AA is equidistant to sites J and N. So J and N. Find the value of A. So any point on the edge here between J and N would be satisfactory. So it's not a specific answer. But for example, you could pick this one here, which looks like it's 40, 40. So there's many answers there. And then find the equation of the edge between sites E and K in the form y equals mx plus b. So we're looking for this edge. So here's the deal with how these edges are constructed. So the edge is going to be the perpendicular bisector of the segment EK. So guess what we did last chapter that we should still be pretty good at? Writing the equation for perpendicular bisectors. And right now Colin's going, dang it. All right, so to do this, we're going to need the slope. So that's going to be the negative reciprocal of the slope EK. And then the point, which will be the midpoint for EK. So I'll start by just finding the slope for EK. So that's going to be y2 minus y1 over x2 minus x1. So that's negative 5 over 2. So my slope for my perpendicular is going to be positive 2/5. My midpoint is just going to be the average of the x's and then the average of the y's. So that's going to give me 10, 21. No. Oh, that's an 18 out of 14. Yeah, so 23. Okay, and so now I'll do like y minus y1 equals m times x minus x1, and then just rearrange. So I'll add the 23 over, and there we go. Okay. So next thing up, we're going to draw or construct a Voronoi diagram for these points. So we're going to draw in our own edges. Okay. So first thing I'm going to do is I'm going to draw in the edge for AB. So remember, all these edges are perpendicular bisectors for the segments. So I'll find the slope for AB. And then I need the midpoint, which is going to be the average of the x's. So that's going to be 4, 3. So I'll plot 4, 3. And then I'm just going to go down 2 and then over 3. So 1, 2 down, 3 over, and then I'll go like 3 to the left, 1, 2, 3, and then up 2, and that's going to be enough. Where's my ruler at? I said ruler. Where are you, ruler? Whatever. So I'm going to have like that going in there. Okay. And now I'm going to do the edge for AC. Well, that's really easy. I don't even need to do anything for that, right? Since AC is right here, I know the midpoint is there, and my perpendicular bisector is just going to be that vertical line, right? Let me actually do a different color. We'll color code this so it's a little bit easier to see. Okay, and then we'll do the edge for BC. Again, I got real lucky. What do I notice about BC? It's a vertical line, right? So I know the midpoint is like right here at 6, 3, and my perpendicular bisector is going to just do that. Since it's a vertical line, it's easy. And then I just need my edge for BD. So this I'm going to have to calculate. So I need the slope for BD. So the slope for my perpendicular there is just going to be 3. My midpoint is 6 plus 15 over 2. 6 plus 3 over 2. Yuck. 10.5 comma 4.5. So 10.5. And then 4.5 is like there. And then I'm just going to go 3 up and 1 over. So 1, 2, 3. Oh, sorry. 3 up and 1 over. 1, 2, 3. And we'll do the same thing in the other direction. So 1 over, 1, 2, 3. So there's that. And now I just need to build or decide which one of the or which parts of these lines do I keep. So for my edge AB, I would keep that part, because that's the part that's dividing like A and B. My edge AC, I'm just going to keep that part, because that's the part separating A and C. For my edge BC, I'm going to keep that part, because that's the part that divides B and C. And then for my edge BD, I'm keeping that part. Oh no, I forgot an edge. I need for D and C. Oops-a-daisy, guys. So sorry. Okay, so 10.5, 1.5 is here. And then I'm going to go going to go 9 down and 1 over. Well, I'm going to actually go 1 left and 9 up, I think, is going to be easier. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, that's way off the chart. So there's that. And the piece of that I want that's separating D and C is, should be going through there, is like this section. So if we kind of just delete out these other parts, that's going to be like my Voronoi diagram. Is that okay? So the hard part is just like doing the construction. I doubt they'd ask you to do the entire construction on the IB exam because it's quite time consuming. But they might ask you to they might have you everything but one point in there, you know, where you have to add 1 point in or something. So here it says use the map of rainfall measurements in the figure there to estimate the rainfall at coordinates 6, 4. So I'm going to just take plot my point 6, 4. Oh my God, stop. Oops. 6, 4 is like right in here, right? So that's closest to P. So I would say that 0.63 should be my estimated rainfall. Everybody's okay with that idea? Again, pretty easy to do. You just have to know what you're looking at. You know what I mean? So the last idea is this idea of the largest empty circle. So canonically, or what this is really talking about is in the real world, there's often stuff that you might want to build that you don't want to build near anything else, right? Can you think of something that you want to build that you don't want to build nearby anything else? Sure. So like sites like a toxic waste dump or a nuclear plant or a prison are oftentimes things that you don't want to build near anything else. Or from a business perspective, if you're going to open up like a pharmacy, where would you want to put your pharmacy? Where there's not any other pharmacies, right? So that's another reverse idea of like you want to find some place where it's like, oh, there's not a lot of this business near here. Let me put it in this, you know, so it covers this area. So the idea is our largest possible empty circle is going to be at a vertex. So if I look at this diagram, there's two possible choices, right? Everybody agree that there's like two possibilities? Now what I'm going to do is I'm going to calculate the length from that vertex to any site that borders it. All the distances from the vertex or from that vertex to any of the bordering sites is going to be equal. So whichever one has of the two possible candidates, whichever one has the bigger radius is going to be the bigger circle. Pretty obviously we can see it's the green one, right? So I would just say like 10, 3. Oh, it also wants the radius. So there's my center. My radius is going to just be the distance from 10.3 to 6.6. So when I do that, I get 5. But that's the gist of it. That's chapter 5. All of it. We did it. Yeah. Here's what I'm going to ask you guys to do. We have 40 minutes or stuff left here. Why don't you guys pull up your, grab your tablets, open up your OneNote. What I'm going to do is I'm going to drop in a couple of these Voronoi diagram problems that have like the graph paper already attached to them. And we're going to, ask you guys to do some of these. So like here's one that I've put in. So don't do it in the collaboration space, like just copy it into your notebook or whatever, but
So if you were to say like the same definition of something into like another word, I would click that one. But like
that's really a great skill to have, Maya.
like if they put the same definition into 2 different words, I wouldn't know which one it goes to. Huh? You get a multiple choice. Okay, right. If it put the same definition for one word and then that same definition for another word, I wouldn't know which one it goes to. Oh, okay. I just know what the right answers are, and wrong answers are the component.
Oh, okay. You have to memorize the group, not the actual word. That makes sense.
And this all we're touching over there. Yeah. Yeah. Yeah, I know. I don't have her. We were talking to lunch. She was like, so tired or whatever. Just go. No one's stopping me. Did you hear me get yelled at? Oh, yeah. I'm Miss Lyle yelled at me. Not going to my car.
Oh, yeah.
Like, did I? Yeah, she's okay.
I've never
So do I. No, she gets so mad.
Are you in the game class?
Yes. It's so bad. Like, can I go to that one?
Yep.
That's pushing a little bit.
No,